Okay, I realized how long that video was, and I'm trying to make sure that these are short videos, so I'm just going to blow through this real quick for this kind of FRQ. It's really a good FRQ, and I would highly suggest you know every aspect of it. So basically, the first problem for part A is find the area R, so here's R. And to do that, you're simply going to define what the intersection point is. It appears that it would be 1, but it's actually 0.942, so again, second calculate intersect, you get these values. Make sure you have both the x and y coordinates because you will need it for later. Next, here, define what your A is, or any letter, just what you're integrating from, just so it's easier to understand where exactly you are integrating. So you integrate by doing top function minus bottom function, so this is the upper value from here, so top minus bottom. Then you just integrate from there, dx. Here's what you would get for your area between the two curves. Then you move on to volume, and you're rotating about the x-axis. So this is the formula you would need to find the volume. It's big R squared minus little r squared, so that is here. The big R is the let me put it here. Here would be the big R, here would be the little r. I kind of put it there already, but that's just representing radius. So when you rotate it this way, yada yada, you just have to know which, because there'll be a hole created here, or there won't be, it depends. And then you would just, so the capital R, the highest function, was e to the negative x squared for our regions. And then little r, 1 minus cosine x squared, and make sure you square both terms, because a lot of people just put a squared here and don't square each individual r. And since we're doing this with respect to x, 0 to a, pi is here because when you're rotating it creates a circular region, so there's that, and its volume, so units cubed, but you guys don't need to care about that. So cross-sections are easy. It's basically cutting something, and they're saying if you were to cut, and if you look at the face of the cut, like if you cut a piece of bread or something, it's a square. So to find the volume, you would add up an infinite number of area of squares, or it's not infinite, but a certain number. So to find the area of a square, the formula is side squared. So since we're doing this with respect to x, same limits of integration, 0 to a. Then the top function minus the bottom function is the one side. So here's what the graph looked like. It's like if you were to create a square, oh my god, square, and since it's 3D, that's why it's popping out, I'm trying to, but it's just the length of one side, and that's the one side. And that's why I tried to show here that that's one side. So you're going to have to square it, since the formula is side squared, and then dx you would get 0.461 units cubed. Alright, this one was the hardest one, I think, in the whole problem, so I'll try to spend a little bit more time on this, but you're finding volume, but rotating it about the y-axis, so you're flipping it this way instead of this way. So what you're doing is basically, I wrote these out, but in the previous video I solved for each one on how to do it. You can watch that if you want to. But it's basically the original functions that were given. This one was e to the negative x squared, and this one was 1 minus cosine x, whatever. And basically, you just have to solve for x, since you are going to be doing this with respect to y. That's why you must keep them here. So basically, another important thing is that you have to split up the integrals. So notice how it's 0 to c and then c to 1. The 1 is that's supposed to be, the green line is supposed to be hitting the y-axis, so like on a maximum value there, or local max. Hold on 1 second, go. Okay. See how I drew these lines here? That's basically each radius, instead of the radius going upward, it's going sideways, and since you're going to be flipping it that way, yada yada. So if you were to just integrate from top minus bottom from 0 to 1, it would add up each, like pretend these are all radii here, and the other one would be here, and you would not be getting anywhere near close to the correct value. So, and also, this is what since you're doing it with respect to y, this value is now important. So it's like 0 to 0.412. I define it to be the letter C and box it. It's easier that way so you don't get confused. Here, this is R1, R2. If you look at the slide back there, I'll show you basically it's each radius, and you're going to flip it, so you got to use pi. And, all right, so let's go back here. So I defined C, you saw that. I separated the values because, like I said, you would be integrating incorrectly. So 0 to C, C to 1, R1 was here, so this is R1 or R2, whatever. I had it to be, I think I might actually switch that honestly, but alright, and you would get approximately 1.259 units cubed, and that's volume with, remember, dy, so with respect to y. Last thing, arc length perimeter. This is really easy. It's pretty much, this is the formula, and pretty much it's plug and chug, honestly. But if you can derive this formula, it's good because you'll understand the concept better. I defined the functions to be these two. I just made them my own, so I could just plug this in easily, so I wouldn't have to worry about writing all of them out. But since we're doing this with respect to x, we're going to go back to using a, like we already previously defined. So this is the arc length, so the perimeter of, here's what the graph kind of looked like. It's saying this area, this perimeter, and that perimeter. But people forget to include the y-axis, so I'll go back to that. This is also included in your perimeter. Since you're doing it from 0 to something, that is included in perimeter, and it's usually a big mistake, so always make sure you have all the sides added up. And I just did this individually if you're curious to know what the perimeter or arc length, depending for each portion was, and then you add them all up, and that's what your answer would be. All right, thanks.